Alright, now we will take percentage comparison of two quantities, like more or less. How do we do that? First, let me give you the theoretical aspect. It is same as the percentage change which we are going to do in some time. But here, when I say A is what percentage more than B or even less than B. So whether it is more or less, the formula is going to be the same. How? Let's see. First of all, whatever comes after preposition, than is a preposition, will be the base. So in denominator, we will have the base, that is B. More or less means the difference. Okay, into 100. So when I say A is what percentage more than B, it is the difference divided by B into 100. And the difference can be written as A minus B by B into 100 if obviously A is more than B, and it will be B minus A by B into 100 if A is less than B. Obviously the question will be different. For the first one, it will be by what percentage A is more than B, and for the second one, by what percentage A is less than B. But the important thing is to understand that it is the difference value divided by the base value into 100. Right? Whatever comes after preposition will be the base. Let's take some example. If I say that in an exam, A got 60 marks and B got 75 marks. Right? A's marks are what percentage less than B's marks, and similarly B's marks are what percentage more than A's marks. Right? Let's see. Look at the expression, it says difference. So here we have A as 60 marks, B has 75 marks. What percent less than B? So less than B. So than B, that means in denominator we have B. And in numerator, what percentage less than B? So obviously difference value, B is higher, so B minus A into 100. Just try and read this statement and directly apply this expression. Nothing else has to be thought. Difference value divided by the base value. Right? Which one is higher, which one is lesser is already visible in the question. So it is 75 minus 60 divided by than B. So it is 75 into 100. Now 75 minus 60 is 15 upon 75 into 100. Now 15 cancels 75 5 times. 5 cancels 100 20 times. So the answer is 20%. So we say that A is 20% less than B. A is 20% less than B. Okay, the base is B. Now let's look at the other one. B's marks are what percentage more than A? Can we say that B is 20% more than A? No. The percentage cannot be calculated in the reverse. That we'll see in some time. Alright. Here the process will be different because now the base is A because that comes after than. So now we have to compare with A. So it will be equal to, in denominator will be A and B more than A. So still the difference value remains same, B minus A. Please understand the difference value remains same whereas the base changes. Right? So it is 75 minus 60 divided by A, that is 60 into 100. So it is 15 divided by 60 into 100. The base becomes, this quantity becomes always the base. The quantity with which you have to compare becomes the base. So 15 4s are 60. 4 cancels 125. So it is 25%. Right. So if we say that A is 20% less than B, that means B is 25% more than A. Right. This is one very interesting story, that it is not the same percentage that changes. Okay. If one quantity is some percentage more than the other quantity will be some different percentage less than the other one. You have to be really particular and careful about this situation. Because the base changes. Please understand that this 20% is of B, this 25% is of A, whereas the value difference is the same. Okay, you have to be really careful in such situations. Let's take some more questions. Now, this question says A's income is 80% of B's income. By what percentage B's income is more than A's income, right? So here, is given 80% of B. So let's assume that B's income is equal to 100. That means A's income will be equal to 80% of 100, that is 80. So it is 100 rupees and 80 rupees. Now read the question carefully. What is it asking? What percentage, by what percentage B's income is more than A's income? So more than A. So this answer of this question will be A will come in denominator and B is more than A. So B minus A will come in numerator into 100. Right? Now whatever is the value of B and A, put them there. B is 100, A is 80, so 100 minus 80. Divide by A is 80, so divide by 80 into 100. So it is 20 by 80 into 100. So 20 cancels 80 4 times, 4 cancels 100 25 times. So the answer is 25%. This is one very interesting situation, right? So if A's income is 80% of B, that means B is 25% more than A's income. Okay, so you have to be little careful in these situations. Now this question, B is thrice of A. By what percentage is A less than B? Right? So B is thrice of A means B equal to 3A. The question is by what percentage is A less than B? Right? So for this question, the answer will be directly than B. So niche in denominator we will have B and less. A is less than B. So difference value B minus A into 100. This is what we have to calculate. In place of B, put 3A minus A divide by, in place of B, put 3A into 100. So we have 2A upon 3A into 100. So A and A are cancelled. 2 by 3 into 100 is 200 by 3 percentage. So it is 66.2 by 3% or 66.66 percentage. Please understand what is this 66.2 by 3%? A is 66.2 by 3 percentage less than B. Right? So please be careful. Whatever quantity we want, whichever quantity comes after than will come in denominator. And in numerator, we will have the difference according to the situation. Right? Okay, now let's go to the next part. Now we will take up the next segment of the chapter percentage, that is net change. Let's say net change. How do we calculate net change? Net change is calculated as final value minus initial value divided by initial value into 100. Right? So it is net percentage change. So net percentage change is actually equal to, instead of final value we can just write F minus I upon I into 100. So this is the simplest formula for net percentage change. Let's take some examples. If I say that the price of a house changes from 250,000 rupees to 3 lakh. Find the percentage change. So what we do is we straight away say that the percentage change is equal to final value. This is final value. This is initial value. So it is 300,000. Follow this formula. Final minus initial upon initial. So final minus initial divided by initial into 100. Now 3 lakh minus 2.5 lakh, it will be 50,000 divided by 2 lakh 50,000 into 100. So 4 zeros and 4 zeros are cancelled. 5 cancels 25 5 times and 5 cancels 100 20 times. So it is 20%. Also you can see that there is an increase. So we say 20% increase. So the answer of this question will be 20% increase. That is the percentage change. Oh, that means there is a situation. There may be a situation in which the decrease happens. Okay, so first let's take some more examples. Let's say in a class there are 60 students. Find percentage change if 15 more students join, right? So here initial value is 60. It's already given that 15 more students join, right? So though the final value is not given, it's already the difference value, that is final minus initial, is already given 15, right? So 60 were already there. 15 more students join. If necessary, you can find the final number of students. Final would be 60 plus 15, that is 75. Alright. So this f minus I, 15, is the difference value which is already given. So in this case, the percentage change will be equal to the difference value 15 over 60 into 100. So 15 cancels 60 4 times, 4 cancels 100 25 times. So the answer is 25% increase. Very simple situations. We just have to see that what is the original value and what is the difference value. Alright, so I have written the summary here of the formula here, that net percentage change is calculated as final value minus initial value upon initial value into 100. Or we can also say, in place of final minus initial, directly the difference value divided by the initial value into 100. So I have written the descriptions here. F is the final value, I is the initial value, F minus I is the difference value. Let's take some more examples. Now in this question, it says the price of a bike changes from rupees 36,000 to 24,000. Rupees 36,000 to rupees 24,000. Find net percentage change. A direct question. The initial value is given 36,000. The final value is given 24,000. Here there is a reduction. But in any case, what is the difference value? The difference value is equal to final minus initial. That is 24,000 minus 36,000, which is 12,000. You can also say it is minus 12,000, right? So minus sign can simply be mentioned as a decrease. So 12,000 decrease, right? So the percentage change, don't worry about the minus sign, just look at the decrease value. So net percentage change is equal to the difference value 12,000 divided by the initial value, that is 36,000. See, 12,000 has decreased on 36,000. That is 12,000 divided by 36,000 into 100. So this becomes 12 3s is 36. So 100 by 3%. 100 by 3 is either 33 1 by 3%, or you can also present it as 33.33%. And don't forget to mention that it is a decrease. So the answer to this question would be 33.33% decrease. Alright. Alright, now let's take this question. It says, a person spends 60% of his income. That means he saves remaining 40%. If his income increases by 20% and expenditure increases by 30%, find the following. The first question is new percentage saving out of the, obviously, the new income, right? So it by default it means out of new income. Okay. The second question is percentage change in saving, or the same thing can also be asked like this: by what percentage does the saving change? These two are the same things. Percentage change in the saving. So basically we are talking about saving value. Okay. Or by what percentage does the saving change? So saving value change is the same thing. Now the next question, percentage change in percentage saving, right? Or by what percentage does the percentage saving change? So here we are talking about percentage saving. Okay. And then the fourth one says, by what percentage points does the saving change? Now please note, percentage point is a new term that is used here. We'll explain it in detail. Now let's take one by one. And now, how do we start? So here we'll use the base. Let's assume that the original income is 100. Let original income be equal to 100. Then in that case, the expenditure will be 60% of 100. 60% of 100 would be equal to 60. So the saving, these are all original values, right? So saving will be equal to 100 minus 60. 100 minus 60, that is equal to 40. So we have original income 100, original expenditure 60, and original saving 40 rupees. Let me put the unit also. It is rupees, right? This 60 is also rupees. This 40 is also rupees. Alright, now, in the new situation, what is happening in the new situation? The income is increasing by 20%. So whatever is income here, let's increase it by 20%. Right? How do you increase anything? You add the value. How do you add in this case? So original income is 100 plus 20% of 100. Now 20% of 100 is very easy to calculate. It is 20. So 100 plus 20 is 120. So the new income is 120. Alright. The expenditure increases by 30%. So what is the original expenditure? 60. So this has to increase by 30%. So what will it become? Original income expenditure 60 plus 30% of original expenditure, that is 60. Now 30% of 60 calculated, 10% of 60 is 6. So 30% will be 18. 60 plus 18, that is 78. The 78 is the new expenditure. Alright. So what about the new saving? New saving you have to calculate from here and from this income and expenditure. So the new saving will be equal to the new income, that is 120, minus new expenditure, that is 78, which is 42 rupees. So all these are in rupees. Alright. So this is 78 rupees, this is 120 rupees. Okay. Now let's look at the questions one by one. What is the first question? New percentage saving. The first question says new percentage saving. That means what we have to do is simply the new saving, because it is out of the new income, divide by new income into 100. Please understand that the way we had 40% saving initially, 60% expenditure, so 40% saving. So the same way we are asking what is the saving percentage in the end. So it is new saving upon new income into 100. So it is 42 divided by 120 into 100. 0 and 0 cancel. 6 2s are 12, 6 7s are. 2 cancels 10, 5 times. So the answer is 35%. So the new percentage saving is 35%. But please understand that the base is different. Here the saving was 40% out of 100. Here the saving is 35% out of 120. Right? Be a little careful there. Then the second question. Percentage change in the saving value. Now, what is the original saving? Original saving is 40 rupees. What is the new saving? New saving is 42 rupees. Question is, what is the percentage change from here to here? From 40 to 42. So this becomes initial value. This becomes final value. And we know the percentage change is calculated as final minus initial divided by initial into 100. Right? So in this case, it will be 42 minus 40 upon 40 into 100. We can visibly very clearly see that the saving value has increased. Right? So it is 42 minus 40 divided by 40 into 100. Now 42 minus 40 is 2 by 40 into 100. Right? So 0 and 0 cancel. 2 cancels 4 2 times, 2 cancels 10 5 times. So it is 5%. And this is 5% increase. See, the saving value has increased. So the answer will be 5% increase. Now this is a very tricky situation because a lot of people would mark answer as 5% decrease. But that is not the situation. Right? Please understand the contribution. The component saving percentage is 35%. Here it is comparison. Comparison will happen only from 40 to 42. Right? And that is 5% increase. Okay? The percentage share has decreased by 5%. Right? Percentage share of the component saving, that has decreased by 5%. That will come in some of the questions. But here in the second question is very clear that original saving value is 40 rupees. New saving value is 42 rupees. So it has increased and it has increased by 5%. Alright. Now let's look at the third question. What does the third question say? It says percentage change in percentage saving. Right. So original percentage saving is 40%. New percentage saving is 35%. Right. So from here to here, what is the change? That is the question now. Right? So you have to be very careful about the unit. So here we are already talking about percentage saving. Okay. So original percentage saving was 40. New percentage saving is 35. So the percentage change in this case. So from this item to this item, the percentage change will be equal to final minus initial upon initial into 100. So this will come out to be minus 5 upon 40 into 100. This is 5 cancels 48 times, so it is minus, and 20. This is cancelled by 25 by 2, so it is minus 25 by 2. That is minus 12.5%. How do we say this? This is 12.5% decrease. Please note it carefully. It is 12.5% decrease. Okay. So the saving value has increased by 5%, whereas the saving percentage has decreased by 12.5%. Alright. Please understand the bases are different in these cases. Original case, the base was income 100 rupees. New case, base was income 120 rupees. Right. So nothing to worry. Be careful about the words of the question. Identify the units accordingly. Okay. And then the fourth one. In the fourth one is just a term that needs a definition. Percentage point. Percentage point is a simple difference of percentages. Remember, percentage point, it is equal to the simple difference. It is by default, it is the simple difference of percentages. Right? It is by default the simple difference of percentages. And it's saying percentage points does the saving change. So whether it is mentioned or not, it has to be taken as percentage only. Right? So original saving percentage is equal to 40%. New saving percentage is equal to 35%. So the answer of fourth question would be, I'll simply write percentage point difference will be equal to 35 minus 40%, which is minus 5%. Or we simply say 5 percentage point decrease. Remember not to forget to mention the word point. When we say 5 percentage point, that means it is the direct difference of the percentages. It's just a new term that you need to know. Alright, so this was one very good question which covers a lot of simple aspects in which people get confused. Be always careful about the second question and the third question. In the second question, the unit is rupees saving. In the third question, the unit is percentage saving. Right? And the method remains the same, that is final minus initial upon initial into 100. In this one, 5% increase, that is 40 to 42. And in this one, it is 40 to 35, so it is a decrease in percentage saving. Alright? Now let's go to the next situation. Now let's take up this question. It says the population of a town is 60,000. That is given, is the initial value. In the first year, it increases by 20%, and in the second year, it increases by 10%. Find the net percentage change in the population in 2 years. Now, one thing that you have to assume anyways, always by default, that whatever is the percentage change in the population, it is always on the existing value. So it is compounded, right? Let's try and understand. So initial population, here it is given 60,000. There are many ways of doing this question. First, I'll take this method. In the first year, what is happening in the first year? This value increases by 20%. So what you need to do is calculate 20% of 60,000. How do you calculate? Let's see. What is 10% of 60,000? It is 6,000. 100% is 60,000, so 10% is 6,000. So 20% will be 12,000. This 12,000 is the increment which is added to 60,000. So it becomes 72,000. 60,000 plus 12,000. So it becomes 72,000. This is the population after 1 year. Now what will happen in the second year? Let's see. In the second year, the population increases by 10%. As I said, by default, the next change will happen on the new value and it will keep on happening like this. And that is why I said compounded. Okay. Population is always calculated compounded. So 10% of 72,000, 100% is 72,000, so 10% is 7,200. So 7,200 is the incremental value in the second year. This will get added to 72,000. So the final value will become 72,000 plus 7,200, that is 79,200. So this is the final population. Now what is the question asking? Net percentage change in population in 2 years. So this is our initial value 60,000. Our final value is 79,200. So the net change will be calculated from here to here, right? So straightaway we can say net percentage change is equal to final value 79,200 minus initial value 60,000 divided by initial value, that is 60,000, in 200. Now 79 minus 60 is 19, so it is 19,200 divided by 60,000 into 100. So 1, 2, 1, 2, 1, 2, 1, 2, zeros are cancelled. 6 cancels 192 32 times. So the final answer will be 32%. So the population has increased. We must say that it is increased. Net change is 32% increase. Right? Now, points to note, this is 32, whereas here in first year it has increased by 20%, second year 10%. The simple addition of 10 plus 20 is 30, whereas the answer is more than 30. How did it happen? Because it only happened because this 20 and 10 cannot be added. They cannot be added directly. Why? Because they are not being calculated on the same base. For this 20%, base is 60,000. For this 10%, base is 72,000. You can add percentages only when they are calculated on the same base. Alright? Here they are not being calculated on the same base. Okay? So be very careful. Answer is not the simple addition of 20 and 10. It is successive addition. We will have one more method right now and one more method later on. Right? So let's take one more method here. Here the question is saying initial population is given. Now suppose this population was something different. Let's say some difficult number, 67,283, and still 20 and 10. Then what do we do? Right? In those cases, and even in this case, we'll apply that what we did in the school question where we had 1200 students. We'll apply the same method. We will assume the initial value to be 100. The other method to do the same question is, let's see. Let's assume the initial value to be 100. And I repeat, irrespective of the value given, whatever is the value given, just ignore it. Let's assume that the original value is 100. Okay, and then apply these changes here. So in the first step, then follow the same procedure. The benefit of this method will be whether it is 60,000 given or some difficult number given, doesn't matter, right? Because the answer will depend only on this 20 and 10. Let's see. So initial value 100, right? In the first year, it increases by 20%. So how much will it become? 20% is calculated on 100, so it is plus 20. It is added, so 100 plus 20 is 120. Now in the second year, what will happen? 10% is calculated, and this 10% is on the new value, 120. 10% of 120 is 12, so add 12. So 120 plus 12 is 132. This is the final value. And as you can see, directly the net percentage change here is final value minus initial value, that is 132 minus 100, divided by initial value 100 into 100. Even if you don't do this, you can directly see that the answer is 32%. So that is the benefit of taking 100 as the original value. So this will always be one very prominent method, that we take the original value, the base value is 100, and then we do all the calculations and find the final situation. Alright. And as I said, there is one more way, which is a formula method. And here we'll introduce one more topic, that is called successive change. Okay. So successive change method. For this successive change method, we don't even need to consider the original values. Right. The only thing is, one thing that has to be very clear, that the changes have to be successive, right? Because if the changes are not successive, they are on the same value, they'll simply get added, okay? In this case, changes have to be successive. So if the changes are successive, as you can see in this case, they are successive. How? First this 20% was calculated, then there is a new value. On the new value, the next change is conducted. Now next change is calculated. So if this is the situation, the successive change method can be applied. How is it used? Look at it very carefully. If the two successive, also one more thing, this formula can be applied only for two successive changes. As in this case, there are only two successive changes. So if the two successive changes given in terms of percentages are A% and B%, then their net change or net percentage change, their net percentage change is straight away given by A plus B plus A into B by 100, this much percentage, right? See, if they are conducted on the same value, then answer will be simply A plus B. But if they are successive, it will be A plus B plus A into B by 100. You have to be really careful about the sign of A and B. If A and B are increments, they will be positive. If A and B or any one of them is decrease, they have to be taken as negative value. That's it, right? So if you apply in this case here, A is given as 20%, B is given as 10%. So straight away their net successive change or net percentage change in this case will be 20 plus 10 plus 20 into 10 by 100. Alright. So 0 and 0 cancel. This gives us 2. 20 plus 10 is 30 plus 2 is 32%. So this is one very beautiful situation that this gives us. So there are three ways of doing. One, we take the original value. Obviously, this is not very preferred method. Second, this one will be like always a default method. It will always be useful. And in some cases, you can directly apply the formula. In fact, a lot of cases, you can directly apply the formula only if you know the component changes. So if you know the component changes, if they are successive and you know their sign, whether they are positive or negative, you can directly find a net change using this formula A plus B plus A into B by 100. Remember, only two changes, right? If there are three changes, then what do you need to do? First, find the successive change of, let's say if there are three changes ABC. First, find the net change of this, let's say it is X, by using the formula A plus B plus AB by 100, and then take X and C as a successive to find the net change of X and C. That will be the net change of ABC, right? But in that case, I think this 100 wala method will be more useful. Alright, now the next question, it says it is a question of reverse calculation. Let's see what it means. It says the population of a town increases by 20% every year, right? If the present population is 4,32,000, find the population 2 years ago. Now this is a very interesting situation. A percentage calculation can only be done in the forward direction, right? Remember that. So if there is a value 100, if it increases by 20%, it will become 120. It does not mean that if you reduce 120 by 20%, you will get 100. Let's see what happens. Right? I repeat, if you increase a certain value by a certain percentage, you get a new value. If you decrease this value by this percentage, will you get this value? No. Be really careful here. Let's do that calculation. If I reduce 120 by 20%, what will happen? 10% of 120 is 12. So 20% will be 24. So if I subtract 24, I'll get 96. So the reverse calculation never happens in percentage directly. Then how do we do that? Let's see. As I said, percentage calculation can be done only in forward direction or the way they are mentioned. So here it says the population of a town increases by 20% every year. That means we can assume the population of the town of a certain year and then we can go on increasing. We cannot go backward. Let's do one thing. Here the present population is given and we want the population 2 years ago. So let's assume that 2 years ago the population was 100. Right? Then what will happen 1 year ago? What would have happened 1 year ago? What would happen at the present situation? Let's see. One thing we know that from 2 years ago to 1 year ago, it is a forward situation. From 1 year ago to present, this is also a forward situation. So the calculation can be done. Now, this is a period of 1 year. From 2 years ago to 1 year ago, what will happen? The value will increase by 20%. Okay, so it is plus 20%. This 20% is calculated on 100, so it becomes 120. So the population 1 year ago is 120. Now, from 1 year ago to present, that also is a period of 1 year. In every period, it increases by 20% and it has to be compounded. So again, in this year, 20%, but on this value. Now, 120, 20% will be how much? 10% is 12, 20% will be 24. It is added. So it becomes 144. So we get the present population as 144 if 2 years ago population was 100, right? And this present population of 144 is given 4,32,000. So we'll simply apply the unitary method. So we say that 144, if 144 is equivalent to 4,32,000, then what will be value equivalent to 100, right? So if 144 is 4,32,000, then 100 will be. So it is 100 into cross multiplication method, 100 into 4,32,000 divided by 144. So 144 3 times is 432. You can cancel one by one. So 100 into 3 is 300,000. That means the population 2 years ago was 300,000. Right? So this was a good question to show that you cannot do it directly. Okay. Now, so here one method that we have applied, we have assumed the 2 years ago population as 100. There is another way to do it. Instead of 100, what we can say is, the other method says, let's take another thing. I'll also introduce another concept, the decimal concept. Okay, let's see. Suppose 2 years ago, population was, let 2 years ago population be X. Right? So what will be the population 1 year ago? 1 year ago, population would be, this is a period of 1 year. So in 1 year, what happens? In 1 year, the population is going to increase by 20%. So 1 year ago, the population would be X plus 20% of X. Now if you simplify, it is X plus 20 by 100 X. Now 20 by 100 is 0.2. So X plus 0.2 X. That is X common 1 plus 0.2, which is 1.2 X. Now what I wanted to explain was, this thing you can write directly without getting into the details of this process. If something increases by 20%, it becomes 100 plus 20 by 100, that is 1.2. Suppose it was 10%, what will happen? It will become 1.10. This is 1.20. To memorize it in 2-digit format, right? So I'll just mention like this. I'll give you the initial value, let's say initial value, and I'll give you the percentage change and the final value, right? Suppose initial value is X and there is an increment of 20%. You can directly say it is 1.20X. 0 doesn't mean, but to memorize it becomes easier. Suppose the initial value is X and it increases by 25%. What will happen? 1.25X. Suppose there is a value X and it increases by 50%. What will be the new value? The new value will be 1.5X. You can directly apply these things. This will be really helpful for faster calculation. Suppose something increases by 12%. What will happen? It will be written as 1.12X. Right? Suppose something increases by 100%. What will happen? Now, suppose something increases by 100%, then it must become double. So it will be 2x straight away. Because it is 100, 0.100 is not possible. 0 will be there. So 1 will come up. So it is 2x. Okay. Suppose something increases by 150%. Now what will happen? So for 100% it will become 2 and for 50% it will become 0.5. So it is 2.5x. Right? So whatever is the incremental percentage, it will just come after decimal. Right? So it is 1.50x and so on. The same thing can be applied for decrease also. Let's see how. If there is an initial value x and that decreases by 20%, how do you write it? So the way we did 1 plus 0.20 for 20% increment. Similarly, it will be 1 minus 0.20. You can directly write it as 0.80x. What you can also think is, you can add or subtract this value to 100 and put a decimal after 2 digits. Right? So 100 minus 20 is 80. So it has to be 0.80. Let's say if something decreases by 15%, how would you write it? 100 minus 15 is 85. So it will become 0.85x. You know, if there is a value that decreases by 25%, so how will you write it? 100 minus 25 is 75. So it is 0.75x. If there is a value that decreases by 78%, how would you write it? So it is decreased by 78%. So it becomes 100 minus 78, that is 22. So 0.22x. Right? So this thing can be done directly. Right? So original value, if you know the percentage change, you can directly multiply the original value by a certain thing and you can write the final value. Okay. So having done this and seeing this calculation, what I can do is I can remove this and we can simply say that let the population 2 years ago be X. So the population 1 year ago will be just plus 20%. Now when we are adding 20%, 100 plus 20, so it is 1.20x. Then present population, what will be the present population? Now this is very important. We have the original value here as 1.20 and this increases by 20%. So what will happen? For this 20% we'll multiply 1.2 and the original value is 1.2x. So it becomes 1.44x. This 1.44x is given 4,32,000. So 1.44x is equal to 4,32,000. So x is equal to 4,32,000 divided by 1.44. If you remove decimal, you will get 4,32,000 into 100 divided by 144. 144 cancels 432 three times, and it is the same calculation which gives us as 3 lakh as the answer. Alright, so either you can use 100 as the base or you can use x as the base, and then remember this, how to multiply, how to get the new value whenever it is increased. Here, just remember, for this 20% we multiply by 1.2 to the original value, in this case 1.20x. Now, the way original value here was x, and for this 20% we multiplied by 1.20. Similarly, here this 20% is on this, so this whole value into 1.2, and so on and so forth. Right? This we could have done in the previous question also. Go back and check. Now we will take successive changes in a little more detailed manner. Okay, and let's see how we can apply. Let's take some questions. The price of an article increases by 20% and 25% successively. Find net percentage change in the price. Again, there are two ways, right? And in this question, I'll use both the methods. Let's say original value or initial value, initial price is 100 rupees. So first, it increases by 20%. So plus 20%. 20% on 100, 20 is added to 100, it becomes 120. Then 25%. This 25% is successive. Successive means on the new value. Whenever there is a word successively, right? Except population, every time it has to be mentioned, because in population it is always successive, right? By default. But in other cases it has to be mentioned. So 25% of 120. Now 25% of 120 is 1/4. 1/4 of 120 is 30. 30 is added to this. So it becomes 150. 150 is the final value. And as you can see, from 100 to 150, the net change is 50. On 100, so it is 50% increase. So the answer of this question is straight away 50% increase. Right? Base is 100, so difference is 50. So this percentage change is 50%. Alright? Or the other method is direct method, the formula method, that's successive change method. That is equal to A plus B plus A into B by 100. Right? As you can see, in this case, A is plus 20 because it is increment and B is plus 25. You have to be careful that you have to put the sign of A and B always. Right? So A is plus 20, B is 25, plus 20 into 25 divided by 100. So 20 cancels 100 5 times, 5 cancels 25 5 times. So 20 plus 25, 45 plus 5, that is 50. So 50% increase, right? This will automatically come out to be positive if it is increased, and it will come out to be negative if there is a decrease. All right. Now, so let's take some more situations. What I'll do is I'll write like this: first change, second change, right? And let's say question number 2. So I'm keeping the same question. The price of an article changes by these two changes, first change and second change, okay? And you have to find net percentage change. Okay, let's see. If I give you the first change as 10%, second change as 25%, what will be the net change? So what I'm trying to say here is it is the same question, it is just that I'm changing the percentages now. So if I'm not mentioning the sign, by default the sign would be plus, right? The negative sign always has to be mentioned. Or there's another thing, 10% increase, let me put it this way. And this is 25% increase. Okay. So the net change can be directly calculated as 10 plus 25 plus 10 into 25 by 100. Now 10 plus 25 is 35. plus 10 into 25 is 250, by 100 is 2.5. So the answer is 37.5% increase. Right? Let's take another question. If I say 20% decrease and 30% increase, now what will happen? Let's see. So our net change formula is A plus B plus AB by 100. We are taking successive only. So our net change formula is A plus B plus AB by 100. But here we have to be really careful that A is minus 20%. B is plus 30%. So you have to mention the sign in the formula very clearly. Decrease has to be taken as negative change. Increment has to be taken as positive. So here in place of A we write minus 20 plus 30 plus minus 20 into 30 divided by 100. So this becomes minus 20 plus 30 is 10 minus 600 by 100. 0, 0, 0, 0 cancel and we have 10 minus 6, that is 4%, and it's still positive, so it is 4% increase. Alright, be a little careful here. Now let's take another situation in which we say that the first change is 15% increase and the second change is 40% decrease. So what will be the net successive change? Let's see. So here A is plus 15, here B is minus 40. So what will be the net change? You can directly calculate the net change as A plus B plus A into B divided by 100. So this becomes A as plus 50, B as minus 40 plus A as 15 into B as minus 40 divided by 100. So this becomes 15 minus 40 is minus 25 minus 15 4 is 60. So 600 by 100. So 0, 0 cancelled and we have minus 25 minus 6, that is minus 31%. And this means that the net change of these two successive changes is 31% decrease. So negative sign means that there is a net 31% decrease. Alright. So this is how this formula of A plus B plus AB by 100 can be applied. There is one important thing. Look at the formula. Even if I write it as B plus A plus B into A upon 100, doesn't matter. The outcomes will remain the same. This means that the order of the changes does not matter. Which change is executed first or which change is executed later, the answer will remain, will not be affected on the basis of the order. Okay. Now let's take some more critical example of successive changes. Now this question says the length and breadth of a rectangle increase by 20% and 30% respectively. Find the net percentage change in area. So the length increases by 20%. Breadth increases by 30%. You have to find the net percentage change in area. Let's see. We know that this is the shape of rectangle, right? I hope it looks like a rectangle. Now, suppose this is the length, this is the breadth. What is the formula of area of a rectangle? We all know area of a rectangle is length into breadth. Okay. Here in this case, we are saying the length is increased by some percentage and breadth is also increased by some percentage. We'll get to that geometrical aspect of it. First, numerical process. Let us assume that the original situation, length is equal to 100, breadth is also equal to 100. Doesn't matter because square is also a rectangle only. So you can assume any value. So original area will be equal to, let's say it is 100 meter, 100 meter. So it is 100 into 100 meters square. That is 10,000 meters square. This is the original situation. Now in the new situation, what will happen? Length will increase by 20%. So whatever was the original length, it has to increase by 20%. So it becomes 120 meter. Whatever is the original breadth, it increases by 30%. So 100 increases by 30%, the new breadth will become 130 meters. So the area new area will be equal to new length, that is 120 meter, into new breadth, that is 130 meter, which is equal to 120 to 130 is 15,600 meters square. So we have to find the percentage change from this value, original area, to the new area. This is our initial value, this is our final value. So the percentage change in area will be equal to 15,600 minus original value. This is final minus initial upon initial into 100. Into 100. So this gives us 5600 divided by 10,000 into 100. 0, 0, 0, 0, 0, 0, 0, 0. So answer is 56%. So this is one way of doing this question. This is the proper method of doing this question. Okay. Now let's see if we can apply the successive change method in this. Right. Look at the geometry class. So this is standard procedure. There is nothing. This is a pure conventional method. Everybody can think about it. That assume the original value separately, find the new value separately, and then calculate everything that is required to be done. Now let's look at whether we can apply the successive change method in this case or not. Now in a rectangle, is it possible that you increase the length and increase the breadth simultaneously? Can you change the length and breadth simultaneously? No, it won't. Why? It won't be possible because, see, the rectangle should not lose its rectangleness, right? It should not lose the property of being rectangle, right? At any point in time. So what we have to do is, any change has to happen only one by one. Okay, so the change in length has to happen once. Let's see how. How do you change length? Hold this breadth and stretch, shift, right? So if you draw it, if you shift it here, you can see that the length has increased, right? And this would be gone. I'll just put it like this. So the length has increased. You see, this is L. This is the incremental L, right? And what is the incremental L? It is 20% increment in length. Do you realize that the area also has increased just by changing length? You know, for example, if I have, let's look at this rectangle. This is the length. This is the width. If I simply double the width, what will happen to the area of rectangle? Look at this carefully. If to double the width, I just open it. So as you can see, the width has just doubled. Can you see that the area is also doubled? So any change in any of the dimensions will have its effect on its area. Let's look at it once more. If I increase the width by 50%, what will happen? Look at this. This is the width. 50% will be this much. If I just increase the width, you can see that the area also. Now this strip is exactly half of the area of this rectangle. That means any change in the length or in the breadth will have the same effect on the area also. What does it mean? If the length is increased by 50%, area will also increase by 50%. If length is doubled, area will be doubled. If length is half, let's say for example, if this is the length and if it is half, you can see that the area is also half. So whatever percentage change happens, look at this carefully. This was the original length. If I reduce the length by 50%, that means I make it half. The area also becomes half. Then I reduce the width by 50%. Area also becomes one half. But you see, if I do both changes, then what will happen? Reduce the length by 50%, reduce the width by 50%. So the net area becomes 1/4 of the original area, only this particular segment, right? And this particular segment, remaining portion, is the 1/4 of the original area. Okay? So what you need to memorize is, whether you understood this or not, no problem. Just memorize that whatever percentage change happens in length, the same percentage change will happen in area. Whatever percentage change happens in breadth, the same percentage change will happen in area, right? But one by one. Oh, so that means we can apply our original method, one more method that we had. We can assume original area to be 100. Then, because length has increased by 20%, so I'll increase area by 20%. Just now we said, whatever is the percentage change in length or breadth, the same percentage change will be applied in area. The only condition is one after the other. So area will increase by 20%. I'll write due to change in length. So due to change in length, area will change by 20%. Now 20% of 100 is 20. If it is added, it becomes 120. Now there is one more change that is required to be done. The breadth is increased by 30%. So the area will increase by 30%. As we said, the effect of change in length and breadth both will be there on the area. Now, this 30% again is calculated on 120, and this is due to change in breadth. right? Now 30% of 120, 12 threes are 36. So 36 is added, so it becomes 156. This is the final area, right? I repeat, whatever percentage change happens in length and breadth, the same percentage change will happen in area also, but one after the other. Okay. So initial area 100, final area 156, net change, as you can see, it is straight away 56% increase. And because we could do this, we can also apply successive change method as well, right? So this is our A, that is 20%. This is our B, that is 30%. So the net change is directly calculated as 20 plus, the other method would be, one more method would be 20 plus 30 plus 20 into 30 by 100. 0, 0 cancel. So we have 20 plus 30, 50 plus 2 into 3 is 6, that is 56%. 56% increase. So remember, if the percentage changes in length and breadth are given, the net change in area can be directly calculated with the help of successive change formula, that is A plus B plus AB by 100. Okay, if the net change has to be calculated and the changes in length and breadth are given, you can directly apply this. Okay, it may be decrease also, but doesn't matter, just be careful about the sign of A and B here. Alright, I'll show you physically as well. Let's see. I'll remove this, and here, suppose we increase the length by 20%. Now this is the new rectangle, and this entire thing is the breadth now. This is the breadth now, and this entire thing is the length now. So if I have to increase breadth, what do I do? This is breadth B, this is breadth B. What do I do? Hold this length and push so that it comes here, right? So this thing is 30% of B. So the net change in area, as you can see, this is the change in area, this is also the change in area, and this is the extra change in area. So if you can try and understand, this change was 20%, this change is 30%, and this value is actually that 20 into 30 by 100%. If you don't understand it, this fine, no problem with that. But physically also you can see that. Hence you can directly apply the successive change method. Let's take a couple of more examples. What I'll do is I'll give you a simple table, and from there we'll try to find net change in area. So let's say I put it like this: percentage change in length, percentage change in breadth, and you have to find percentage change in area of a rectangle. Which rectangle? For which the changes in length and breadth are given. So let's take questions one by one. So you have to remember, if the percentage change in length is given A%, percentage change in B breadth is given as B%, the percentage change in area is directly calculated as A plus B plus A into B by 100. No other thought should come, right? So let's say question number 6. Suppose length is increased by 50%, breadth is increased by 30%. What will be the change in area of rectangle? So it is straight away 50 plus 30 plus 50 into 30. This is what you have to find. Divide by 100. So 0 and 0 are cancelled. 5 into 3 is 15. 50 plus 30 is 80 plus 15, that is 95%. So the area increases. 95% increase in area. Now let's take a situation in which things decrease, the values decrease. Suppose we say that the length increases by 40% and the width or the breadth decreases by 30%. Now what will happen? Let's see. Formula remains the same. Just be careful, in place of A we will take plus 40, in place of B we will take minus 30. Okay? Right? Minus sign is decrease. So it is 40 plus minus 30 plus 40 into minus 30 divided by 100. 0 and 0 are cancelled. 40 minus 30 is 10. 4 into 3 is 12 and minus sign. So 10 minus 12, that is minus 2. This means 2% decrease in area. Okay. Be really careful. Let's take one more example. If we have 20% increase in the length and 10% decrease in the width, then net change will be 20 plus minus 10 plus 20 into minus 10 divided by 100. So 0 and 0 are cancelled. 20 minus 10 is 10 minus 2. That is equal to plus 8, right? So this is 8% increase in the area. So you have to always calculate to the last step. Then only you can say anything about the answer. Okay. Let's take one more example. If we say that the length decreases by 30% and breadth also decreases by 20%, then what is the net change in the area? So it will be minus 30 plus minus 20 plus minus 30 into minus 20 divided by 100. 0 and 0 are cancelled. Minus 30 minus 20 is minus 50. Minus 3 into minus 2 is plus 6. Yes, this is where people make mistake. Minus 3 into minus 2 is plus 6. Minus 50 plus 6 is minus 44. So it is 44% decrease in area. Right? Let's take one more. If I have length increases by 20% and breadth decreases by 20%. Right? So length plus, that is increment, and breadth decreases by 20%. What will be the percentage change in area? This will be 20 plus minus 20 plus 20 into minus 20 by 100. See, please understand that this is the important step. You have to be really careful about the sign here. So 20 and minus 20 are cancelled. Here 0, 0, 0, 0 are cancelled. So it becomes simply minus 4. That means 4% decrease in area. Okay. That also tells us if there is any value which increases and decreases by the same percentage, there will always be a decrease which will be square of this number by 100. As you can see, 20 into 20, 400 by 100 is 4. And this will always be a decrease. That we'll discuss later on also in some other topic. Okay. Now let's take some tricky questions. Now, this question says the length of a rectangle increases by 25%. By what percentage should the breadth be changed to maintain the same area? One thing is very clear, the breadth has to be decreased. Why? If the length increases, area increases. But we have to maintain the same area, so breadth should be reduced. Alright. Now there are two ways to do this. One is the direct successive change method. Here, change in length is A, that is plus 25%. Change in breadth B, that is B. We don't know how much is it, right? So let it be just B. And the net change in area is given as 0. Why 0? Because it's the same area. So no change. No change means 0% change in the area. Alright. How do we use this? We know that the net change has to be calculated as A plus B plus A into B by 100. That has to be 0. Initially, don't worry about B, because if it is decreased, it will come out to be negative. If it is increased, it will come out to be positive. Though we already know in this case. I'm saying in any other case, suppose if you are not able to make out whether it is positive or negative, don't worry about it. Just use the formula, you'll automatically get the required answer. Let's see how. A is 25 plus B plus A is 25 into B by 100. This is equal to 0. 25 cancels 100 4 times. This 25 goes to the other side, so it becomes minus 25. And on this side, we have B plus B by 4. Now, B plus B by 4 is actually 5B by 4 equal to minus 25. Now, 5 cancels 25 5 times. 5 into 4 is 20. So, this gives us B equal to minus 20. As you see, directly finally we get B as a negative value. So, what does it mean? Change in breadth required is equal to minus 20%. And how do we say? It is 20% decrease in breadth that is required. Alright. So this was a good question. Just understand that. Now let's look at another method of this. What will be the other method? Other method is the conventional method where we assume some original value. If I assume original area to be 100, the final area will also be 100. Why? Because we have to maintain the same area. But in between there will be two changes. One change due to change in length and one change due to change in breadth. The change in length is given 25%. So the area will also change by 25%. Right? This is due to change in length. Now 25% of 100 will be 25. So if it gets added, it becomes 125. Now, whatever change happens from here to here, it is due to change in breadth. Right? So this is what we have to calculate. So this becomes our initial value, this final value. So the percentage change for this particular segment will be equal to final minus initial upon initial into 100. So this becomes 25 upon 125 into 100. Now 25 upon 125 is 5 times. It is minus sign. And 5 cancels 100 20 times. So it is minus 20%. So as we have already discussed, minus means decrease. So it is breadth to be decreased. Breadth should be decreased by 20%. Alright. So this was a good situation. Okay. Now let's look at this question. It says the price of tickets at a theatre increases by 60%. And we are assuming that all the tickets are of the same price. So all of them increase by 60%. And the number of people reduces by 20%. We are assuming 100% occupancy initially. So later on, like I said, whatever it was, it reduces by 20%. Find a net percentage change in collection. What does it mean? How do we do this? Before going ahead, let me put it this way first. We did it for area, that is L into B. Right? Look at this very, very carefully. It's very important. If we know the changes in these components, we could find the net change in area. Right? If you know the percentage change in length, if you know the percentage change in breadth, we could find a net change in area as successive change. Alright. This logic can be applied to any situation wherever there is a value P, which is a product of other quantities. So if there are two quantities Q and R, if you know the change in Q as A% and if you know the change in R as B%, if you know these changes, if you know the change in Q, if you know the change in R, then change in P, net change in P can be directly calculated as A plus B plus A into B by 100, this much percentage. Right? So this is one very interesting thing. Not only for area, it is always applicable for all the situations wherever there is a quantity which can be presented as a product of two other quantities. Alright. Now in this case also, how would you calculate the total collection? What do you mean by collection? The total amount of money collected at the end of the day. So total collection is equal to the number of people into the price. Right? It's the same situation. Collection is a product of number of people and the price. The price has increased by 60%. So change in P is given as plus 60%. And change in number of people reduces by 20%. So the change in N is given as minus 20%. So the net percentage change in collection is given as, we can simply apply the formula A plus B plus AB by 100. A is minus 20, B is plus 60. So minus 20 plus 60 plus minus 20 into 60 divided by 100. 0, 0, 0, 0. So this becomes 40 minus 12, that is plus 28. Right? So that means the collection increases by, we say that 28% increase in collection. Right? 28% increase in collection. Okay? So wherever there is a multiplication, and you know the percentage change in the components, you can apply the successive change formula to find the percentage change in this. And reverse also. Suppose this was given, you could also calculate B. Okay? And for any other situation. Alright, let's take one more situation in this. Now, this question is again a tricky one. The price of oil increases by 20%. By what percentage should a family decrease its consumption of oil to maintain expenditure of oil? Right? Let's see. How do you calculate the expenditure on anything? The expenditure will be equal to the quantity into the price. The quantity into the price, right? Here, we have to maintain the same expenditure. So, change in expenditure is 0%. It's already given. Change in expenditure is 0%. The change in price is given as 20% increase, so plus 20. And we have to find the decrease in consumption. Whether it is increase, decrease, it will automatically come. Let's assume this Q is the quantity. Quantity means consumption. Okay. Let's assume the change in quantity is X%. Whether it is increase, decrease, it will automatically come. What we need to memorize that the change in expenditure has to be the successive change of changes in these two items, because it is a product. We have already seen and explained this earlier. So the change in expenditure, which is 0, is equal to the successive change of X and 20. Now, how would you write successive change of X plus 20? You apply the formula A plus B plus AB by 100. So X plus 20 plus X into 20 upon 100. Right? 20 cancels 100 5 times. This 20 comes to this side, becomes minus 20, equal to X plus X by 5, which is 6X by 5. Alright. So X is equal to minus 20 into 5 upon 6, that is minus 100 upon 6, which is minus 50 upon 3, that is minus 16.2 by 3%, or minus 16.66%. So it has automatically come negative. That means that the consumption has to be reduced, right? So we can say that consumption should be decreased by 16.2 by 3% or 16.66%. That is the answer of that question. Alright. So we can directly apply this formula whenever there is a situation where one quantity is the product of the other quantities. Alright. Obviously, there is another way of doing that question. I'll just show you here. Suppose we assume the original expenditure on oil to be 100. Let's start from here. Original expenditure to be 100 rupees, right? Now, if I maintain the consumption, the price increases by 20%. So the total expenditure will increase by 20%. So it becomes 120. But I have to bring it down to 100 again. Why? Because the final expenditure has to be the same as original expenditure. So this 120 has to be reduced to 100. By how much will it reduce? 20 rupees. What is this 20 as a percentage of 120? That will be the percentage change in consumption. So percentage change in consumption is equal to final minus initial, that is 100 minus 120 divided by 120 into 100. So it is 20 by 120 into 100, that is 1 by 6 into 100, which is 16.2 by 3% or 16.66%, and it is decrease, percentage decrease in consumption. We can see it is from 120 to 100, it is a decrease. So this was the other way of doing the same question. Okay. Now this question says the radius of a circle increases by 10%. Find net percentage change in the area of circle, right? We know that the area of circle is equal to pi r square. Here pi is constant, so pi into r into r. R square is r into r. If this r changes, this also must change. Here also this is a situation of multiplication. Area is a multiplication of two quantities. The change in r is given as 10%. The change in this r is also given as 10%. Oh, so that means we can still apply the successive change method. Change in area will be equal to, straight away, a plus b plus ab by 100. So 10 plus 10 plus 10 into 10 by 100. Alright. So this gives us 10 plus 10, 20 plus 1, 21%. So the area increases by 21%. Okay. So this is one very beautiful situation. Wherever there is a product, change in the final quantity can be calculated as the successive change in the component quantities. Alright. Let's take one more question. Now this question says the length, breadth and height of a cuboid increase by 10%, 20% and 25% respectively, right? So the length increases by 10%, breadth increases by 20% and height increases by 25%. Find a net percentage change in volume. We know that the volume is equal to length into breadth into height. Alright, so what we will do is, it's given that the change in length is plus 10%, the change in breadth is plus 20%, the change in height is plus 25%. So what we need to do is, now for 3 changes we don't have a direct formula. So what we will do is, to find the net change in volume, because we have the formula only for 2 changes, what we will do is, first we calculate the net change of these two, let's say it is X%, and then we find the net change of X and 25. So here it will be X plus 25 plus X into 25 by 100, right? We can combine 2 of them at a time. So for this, to calculate this, we need to calculate the value of X. So from here you can see that X will be equal to 10 plus 20 plus 10 into 20 by 100. Now this is 30 plus 0, 0, 0, 0 cancel 2. So it is 30 plus 2, which is 32%. Now we put X 32 here, so it becomes 32 plus 25 plus 32 into 25 by 100. Now 25 cancels 100 4 times, 4 cancels 32 8 times, 32 plus 8 is 40, 40 plus 25 is 65. So 65% is the net change in volume. It is 65% increase, right? So even for 3 changes we can apply successive changes, just that first you have to combine 2 of them, and then the resultant of 2 and the third one we have to combine again. Alright, so this is how there are some tricky questions that can be asked in percentage chapter. Okay, so this is where we'll close this chapter. We'll close this exercise. You go through the theory video again, go through the questions that we have solved here, solve them, try to solve them again on your own. Also solve the questions given in the book and the class exercise. Get back to us if you have any problem. Thank you so much. God bless you. Take care.